a mental differentiation between the kind of two types of data. So you've got chain data and state data. So chain data is like all of the old blocks and transactions and things like that. Blocks, transactions, receipts, headers, that sort of thing. So that's the stuff that I put into the category of chain data. It's like the history is one way to think about it. And the state is the balances of your account and the data that is stored in smart contracts and the code that for each smart contract. So when I'm talking about state, that's what I'm talking about. Your balance, your knots, code, contract storage, that sort of thing. So that's what I mean by state.
Cool. Thank you. All right. Well, thanks, Piper. I think this is really cool. I want to open it up to questions about the project you've been working on. And a few of you have been promoted to co-hosts. So if you just want to shout out an introduction to yourself and ask a question, that'd be great. If not, I've been collecting them on the slide. And we have ranked up votes of which questions people are interested in hearing. So James Hancock is here, Hudson Jameson is here, several other people who are involved in this are here. So feel free to unmute yourselves and say what's up to Piper.
What's up, Piper?
What's up? There is one. I was going to say there is one thing that I think I didn't cover, which was one of the main things that maybe affects people maybe not the most, but that in theory can affect people the most here is the actual UX for running a client. The status quo today is that when you turn your fresh download, you download Go Ethereum, turn it on, and chances are you're going to be waiting many hours or maybe even a day for the thing to sync with the network. And one of the very interesting and coolest things that's come out of some of this research is that in the stateless paradigm, that UX changes drastically. And rather than it taking hours or days to sync with the network, you can go from 0 to essentially full client functionality within just a few minutes. There's some caveats to that, like you still have to download the whole header chain or be willing to checkpoint it. But it turns out that checkpointing the header chain can be quite safe, at least when you allow people to opt into it. So if you're willing to do that, to checkpoint, jump to the head of the header chain, then in a stateless client world, you can download, turn on, and run an Ethereum client and be essentially a fully functional full node within a minute or two, which is just a massive UX difference. It means that we should have more clients actually actively participating in the network because the kind of overhead of running a client gets a lot lower. It's easier to pop it on and off if that's what your kind of use profile looks like, which I think caters to the developer experience a lot better. Most of the devs that I know don't actually run nodes. It's kind of heavy and hard and just intense on your machine. But it'd be really nice to be able to turn the thing on when I need it and turn it back off and not know that I've got to wait another, hour or 2 hours or day for it to catch back up with the network. So something that there's a lot of the stuff that we're doing that really is focused on the protocol and supporting the protocol and doesn't actually affect smart contract devs or things like that. But this is one of the things that will make a meaningful difference in what it's like to be a developer on the Ethereum network.
Cool. All right, I see a few new people who have just joined. Gabriel, welcome. Rob, welcome. I'm going to switch over to the Slido where people are upvoting different questions, and then we can kind of use that as an agenda, since I think people are being shy about unmuting and asking a question. All right.
I can jump in with a question, Kevin, if you want. This is Igor.
Yeah, I was going to say,
go ahead. Yeah, please.
Cool. Hey,
please
Piper.
do, yeah.
So I agree with everything you said. I would just throw out the caveats are especially different if you want to run a validator, because validators have a particular set of conditions that you need to ensure that the infrastructure is there. You never want to double sign anything, and so running a validator is kind of the advanced mode. But totally agree with the developer experience. I can't wait. It's gonna be awesome.
When you say that, are you talking about kind of the way that validators need to be able to kind of get a picture of the Ethereum 1 state, and that if you're running a validator, you might want kind of stronger guarantees about your access to the Ethereum state?
I mean specifically like the uptime of running a validator, because you don't want to.
You're talking about ETH2 validator?
ETH2 validator, yeah.
Got it. Yes.
Prevent slashing, basically.
Absolutely. There are denial of service vectors in the stateless world, and there's something that there will need to be education on, because we're like working towards understanding what the guarantees are. But in the initial days, like in the very early releases, as like clients start to support this, there's a pretty high probability that that it'll be easy to DOS a stateless client off the network. It might be expensive, or it'll definitely cost something, but in the early days, that's probably going to be the case, but we are looking at those things and working on figuring out ways to address them.
I think something interesting, just to make a distinction about stateless Ethereum and then the transition to ETH2, when something that Alexei made in the beginning of us having these meetings was that he's designing this in line with miners being on the net. Like that being like the first step is how to have stateless Ethereum with miners. And then the next step is how do we do it
without it? So I also had a question just regarding like the environments that these stateless clients would go. Are you guys like aiming for super floor level hardware, so like anybody even with crappy internet and devices can run these, or like is there more of a higher ceiling? What are the places that this would be run in?
I think that the lightest weight kind of machine that you can run this on is whatever can do the actual EVM execution within the block time, because that's really kind of the limiter. Is a stateless client is in all intents and purposes has the same security footprint with respect to like validating the chain as a full node, and it's just that it's not reading the state off of a big database on disk. It's being given like, this is the state you need to execute a block, and then it actually does the execution there. So I don't know what that is, but I know that people have synced on Raspberry Pis, which means that we should be able to run stateless clients very easily on Raspberry Pis, which opens up some really cool use cases for like new bricks of hardware that you stick in your house for your own, signer interface or whatever it is that sitting it behind MetaMask. I'd love if my MetaMask was talking to my own node rather than reaching out to Infura, but it's just too much of a pain. But in this model, it might be really, really easy to set up a little box on your network that MetaMask will reach out to on its own. So, yeah.
Cool. That's an awesome answer. So I guess then after that, my follow-up would be, how much users could like a stateless client like that expect to handle? Could you have like 100 just pinging it, or like thousands? Like what would be?
When you say users, are you talking about like issuing JSON RPC requests?
Or just wanting to read the state that's in this stateless client? Like you mentioned your MetaMask reading it, but say it could like 1,000 or 10,000. How many people could connect to that stateless client?
That's a really complicated and nuanced answer, but I'll try to like give the simple version. The nuanced part there is that for a stateless client to say answer arbitrary JSON RPC request, it's going to have to fetch data live from the network because it doesn't have that state locally. So let's say you want to do an ETH call, JSON RPC request, execute, or read your balance from a token. Then it still actually has to reach out and fetch that state over the network live. And that is a bit of an unanswered question right now, of kind of like state providers is one of the things that we're exploring and how that works. One of the ideas that I'm interested in, probably most interested in, but there's not really been any like depth of investigating whether it's viable, is essentially spinning up an overlay network that's like a state provider network that is not necessarily as performant as would be desired if you wanted to sync the full state, but for doing on-demand reads, that it's absolutely adequate for that sort of thing. So I think that the answer is there's a limitation on the actual hardware for like just how many like actual requests can it support. And then there's a limitation on how much state does it have locally and how fast can it fetch it over the network? Does the client implement caching strategies to keep a hold of state that's being accessed regularly? And we kind of call that semi-stateless. The idea of like, I'm just going to keep, a maximum of, 1 million tree nodes, the most recent ones that have been touched. And so you'll always have good information on things that have been accessed in recent blocks. And you probably will have to fetch things we call cold state, stuff that hasn't been touched for a while. You probably have to reach out over the network to grab that stuff. So I guess the answer is it depends.
Cool. Thank you.
I had a question. The EIP 1559, so that is the fee market change for the ETH 1.0 change, but it is also something that they were looking into for 2.0, so it kind of fell in the 1X category, in my opinion. I know that it was initially authored according to the EIP by Vitalik and Eric Connor. Now I'm hearing that like Rick Dudley and a few people from his group have done some implementation and study on it. Where does it stand right now, and who would you consider the main team on it?
I don't think I know enough about that to give a real answer.
Ooh, James might.
I can do it. So first to note that I think ETH1X kind of encompasses more than stateless Ethereum, like saying 1559 fits within it. And the stateless Ethereum initiative is really moving forward awesomely. But I've been keeping my eye on kind of some of these other parts that are happening. And for 1559, Rick Dudley and his team have a PR in Go that this had worked, like done some testing, or at least it is functional in the proof of concept phase, and are doing that. They're the drivers of this. Did that answer your question, or was there kind of more?
Nope, that's it. Thank you so much.
All right. Thanks, everyone. If anyone else has questions for Piper, please unmute and say what's up. And if not, I'm going to move over to the Slido and start reading off some of the questions people put in the Slido.
I like this Slido question. Is state rent dead?
I have an opinion. I don't have a definitive answer.
You didn't even
That's
hear
my
That's all we
opinion.
ever have.
Yeah, my opinion is yes. State rent, implementing state rent is probably as complex as doing what we're trying to do, and gives us less nice toys to play with. State rent essentially just attempts to solve this problem at the core EVM level, charging for state, figuring out, and it. Everything that I looked into, everything that my best understanding of it, there was just no way that you were going to do that without doing contentious, backwards incompatible breaking changes, and it very likely would have resulted in Ethereum Classic. Maybe, I don't know, but like the idea of being able to getting state rent through, it solves that one problem with a whole suite of like contentious, backwards incompatible EVM changes, which is a hard sell because it just fixes that one problem that really doesn't, like, most people don't see it or feel it. So that's a hard push to push through. We are going to have to make some EVM changes, very likely, to get stateless Ethereum like to its finish line point. And some of those are potentially going to have some level of backwards incompatibility, but it's just such a much easier sell because the benefits that come out of it are so much bigger and broader and wide sweeping. So it's dead, maybe even just because this looks like a viable way to fix the same problem while getting so many more nice toys to play with along the way.
I have an opinion too. So first, it's funny to me because Alexi initially got rid of looking at stateless because he thought it would be too complicated and went into state rent. And now we've come full circle to having stateless Ethereum be the one that's less complicated. And if it was, so I agree with Piper that as far as stateless Ethereum is a bigger priority. If it was to happen, it would happen after that, and it would be really still a hard sell to get
done. So one difference, as I understand it, between Alexi's state rent, which I would broadly summarize as sort of like you having to pay your rent for the state that you keep on chain, and Piper's stateless sort of client BlaKCinc architecture, that may not be what you call it, Piper, but is that if each client gets to choose what state they actually persist on their client, then there's a possibility that there's some state that no one wants to take responsibility for, and there's no coordination mechanism for figuring out what that state is. How does the system sort of correct for the fact that no one's responsible for every single piece of data anymore, and the possibility that we could lose that data?
The short answer is that this is an unsolved problem, but the longer answer is that it's probably going to be fine. So we're looking at tackling this through a couple of mechanisms. So the problem that we want to mitigate against is there's, some piece of the state that just nobody has anymore, which you can actually just put into the exact same bucket as there's some piece of the state that only one asshole has and he's holding it hostage, or she, they, Z. So like, we don't want that to be the world that we end up in. And one of the mitigation mechanisms that we're looking at is essentially just requiring that blocks have witnesses before they are propagatable. So it's essentially saying, like, if you mine a block that touches a piece of state that nobody seems to have, then nobody is going to, your block won't make it in, even if it's valid, because nobody else can validate that it's real. So the idea is that miners provide witnesses as part of their job. The nice thing about stateless Ethereum is that witness concept has sort of a BitTorrent swarming behavior to it, in that since everybody needs it and everybody wants it, it generally propagates itself pretty well through the network, is at least conceptually where we're at. The other thing that we're looking at doing is sort of kind of, I guess, like a tiered approach or like a layered approach to fixing this. So there are participants on the network that have just a native incentive to just have all the state. These are big players like Etherscan or Infura or exchanges and things like that. People who have like a financial incentive to have solid infrastructure that they are running that's participating in the network. So on one side, we have confidence that there will be people who are willing to pay the hardware costs, even if it takes somewhat high-end hardware to maintain a full picture of the state at all times. So that's kind of like one layer of the solution. The next layer that we want to get at is making that state available, because what we don't want is for all of those providers to sort of slowly each get DOSed into like being selfish about their state that they're holding on to. Because if it just ends up with just only those people having the state, they may not share it readily, not because they're holding it hostage, but just because they can't, because it's too, the request load is too high. And so we want to solve that through a second mechanism, which is that idea that I mentioned earlier about having sort of a distributed state network. The idea is sharding the state up, so splitting it up into lots of smaller pieces and distributing amongst all of the players in the network and having a mechanism for requesting it. Chances are that mechanism won't be extremely highly performant, the same way that it is today, where you can fetch large amounts of state from an Ethereum client pretty quickly. But the idea is that it can be quite reliable. In theory, you can build that network to be quite robust. And so with those kind of two things, I think we get real close to having enough nines on our, uptime percentage counter, whatever, that the chances of losing a piece of state get close enough to zero for it to be roughly the same as the network today.
I see. I like the sort of architecture, the first answer that you gave, that was, I think it was something to do with it. If you reference a piece of state that no one can find, then it doesn't be included in the block. I think that when I think about someone who launched an ICO in 2017, basically that gives them an incentive to run a client that holds the state for their dApp, which I think is a quite elegant incentive structure, decentralized incentive structure to keep that state. Hopefully I'm saying that correctly.
No,
I'm not quite a protocol dev. I'm just
that's
a web dev.
Definitely right. And it's one thing that I forgot to mention earlier when I talked about different client types, is having clients that only pay attention to certain parts of the state. In theory, it'd be really nice to be able to run your, Go Ethereum node, whatever your Ethereum node is, and have it only store the data for the stuff that you care about and not have such a big footprint on your hard drive and not be as heavy. Similarly, if you're a company running, if you run the CryptoKitties infrastructure, it makes sense maybe for you to not have to have all of the other random contracts out there in your infrastructure and to make that infrastructure that much heavier. So this can make infrastructure costs, even for companies and things, a lot lighter because they can run nodes that only track the accounts and state that they care about.
Great. All right. Any more questions? Go ahead.
Just a quick question. This won't take long to answer. Are EVM event logs like the heaviest or like most storage intense part of the state, to the point where if we rip those out, it would actually be a significant difference? Because I know there was some study that Alexi or someone was doing to see what was the fattest part of the state, and I think that was it.
Events. So this is somewhat orthogonal to stateless Ethereum, but I am kind of rolling it in just because it's part of my broader effort of making it easier to write an Ethereum client. And event logs are one of the really hard things that Ethereum clients have to do. Answering the API requests for event log data that people put towards Ethereum clients is a very heavy thing, because it makes the assumption that you have all of the history, that you have all of the logs, and that's in the roughly, I think we're coming in close. We're somewhere in the 500 million or more, or closing in towards 1 billion log entries that have happened historically. So there's just a huge number of those, and they have to be indexed and searchable and queryable. If you want to write an Ethereum client that exposes the APIs that people expect it to expose. So one of my goals along the way is to actually change those expectations. We want to make it allowable for clients to forget the old chain data. So making it part of the protocol to be able to say, I only have logs for the last, call it, 1 million blocks or something like that. And similarly, I want to take that functionality that exists inside of each client and has been essentially re-implemented inside of each client. And I really am either it's going to get done on my team, or I'm going to find somebody who wants to do it as a hackathon project or a bounty or whatever. But I'm looking towards writing a standalone piece of software that exposes those logging APIs on its own after feeding all of the block data out of an Ethereum client. So my ideal situation is to take those APIs off of the standard, to have them not be standard Ethereum client APIs anymore, and to have that be sort of standalone piece of software that you can run alongside your Ethereum client if you need the logging APIs.
Hudson, you lied. That was not a short answer.
Piper, you're making me lie.
All right. Well, I just pasted some questions from the Slido chat over in the Zoom chat. I'll just read off a couple of them. The first is, what is ProgPow? Any updates on that? Please explain a little bit about that. The second one is...
I can take that one.
Okay, James will take that after, yeah.
Cool. I'll just read off three of them, and that'll just seed the discussion. Also, it'll give you a second to prepare a statement about ProgPow, James. Second is, do you see any issues with implementing EIP 726? That would help ORUs a lot. And then the third one was, will DeFi impact the migration from ETH1 to ETH2? How long will the ETH1 POW chain exist? How can we minimize the migration plan? So I'll just put those out there into the ether, pun intended. And if people want to take a swing at them, then please do.
I just wanted to say that I asked a question about EIP 726. I don't know how familiar you guys are with it. It seems like you can kind of get it for free with a lot of this stuff that you're doing to the stateless 1x, etc. And I wondered if it's on your guys' roadmap. It seems like from the last point I talked to people who are implementing ORUs that it would be incredibly helpful, because right now if you want to implement a general ORU, you have to hack together a lot of ways of basically emulating the stateless execution for the fraud proofs.
What's ORU stand for?
Optimistic rollups. So I don't know if you've looked into 726. Essentially, it's just exposing EVM opcode that takes in the transactions and takes in the multi-proof for the current state, and then runs it in a stateless manner, and then outputs whatever the expected root would have been after the state transition, which seems essentially what 1x is doing, except that's at the protocol level.
This is going to be a short answer, which is that we really aren't looking at this kind of stuff. It's not that it's not important or anything like that. It's more that we have a huge roadmap and a lot on our plate. And so we're mostly only just focused on the things that happen actually at a higher up level or lower level. I don't know what to call it. Different level at the protocol level, and are really actually kind of trying to actively avoid any of the EVM improvements that aren't strictly necessary. So it isn't that I don't think this is a good idea. I really actually like the idea. It's just not something we're focused on within the stateless Ethereum concept.
Do you have an idea of who might be the best people to champion this type of EIP? Because I don't feel like I am the right person to do that. I'm mainly focused on ETH2, Phase 2, etc. But to me, it seems like this is really, really important for the ORU people.
Who were you speaking to, if you don't mind me asking?
About the ORUs?
Yeah.
I spoke to John Adler about them, and I spoke to some of the Plasma Group people, or the optimistic
Optimism,
people.
yeah.
Yeah, sure.
They're probably the best people to champion this, because they're going to know what they need and what they would like to see in the protocol.
It just seems like right now they're focused on making it work with what's there. We recently talked to them, and it doesn't seem like they have the bandwidth at the moment to champion this. It's something that's so far out, and it just seems like it's not even going to be really that possible until 1x is running on mainnet, because there's so many issues with the size of the witnesses that has to be solved with 1x.
In general, for champions of EIPs, it's someone that can do a client reference implementation and then do write tests of that. So if you find someone who cares enough about it to do it, also can do some kind of client reference implementation and then make tests, then you're 80% of the way there.
Okay, cool. I'll just keep banging my EIP 726 drum until I find someone who will implement it for me.
If it's
that can work.
I was going to say, if it's enough of if it's a significant improvement, maybe you could get those groups to collaborate on it. That seems like a viable path. I know they're working hard on rollups and stuff now, but if they could work together on it, that'd probably be good.
Okay, we'll keep monitoring the 1x status too, because I do think that those are going to coincide. I don't expect 726 to hit before the 1x stuff is implemented.
I mean, it won't hit unless there's a champion